All right, so we now have one of the most important definitions in the course. So suppose that L over K is a field extension. A K-automorphism of L is an automorphism alpha from L to L such that alpha of K is K for all little k in big K. So what this is saying is alpha may do some wild things to L, but K, K is a subset of L, right? So it's saying that although it might do some stuff to L, it's the identity on K. Okay? So we say that alpha fixes capital K pointwise is the language we use here. And we can arrange this in a diagram because I love diagrams. So alpha is a map from L to L. And K is a subset of L. So there's a natural sort of inclusion homomorphisms from K into L. And I'm going to put a hook on the end to indicate it's an inclusion. There's a map, an automorphism of K, which is the identity. And that alpha fixes K pointwise says that the diagram commutes. So that is the diagram. You scroll down a touch, commutes. And what that means is, if we were to imagine, we've done this before, I'm going to do it again. If we were to imagine taking a K, a little k, in the upper left spot and sending it over via the identity, well, the identity doesn't change K, and then including K, little k into big L, well, including it just sends K to K, and then apply alpha, that should be the same as just including that little k downwards. And that's what it means that the diagram commutes, and that's how the diagram commuting is equivalent to this statement. All right, if you don't like the diagram commuting stuff, that's fine. You can just remember I have to fix everything in K. So let's go and let's look at what we did earlier when we were, this is the wrong page. Uh-oh. Hang on one second. I don't know how that happened. Let's go here. All right. So let's look at what we did earlier. We had these automorphisms, R, S, T, and the identity. And every element, that these are automorphisms, we would have to argue. We'd have to prove it. And we'll learn how to do that in a little bit. But each of them, R, S, and T, they all fix the rational numbers, right? Like P doesn't, nothing happens to P in any of R, S, or T. So in this case, R, S, and T, from the example, R, S, T, and the identity are actually all Q automorphisms, because Q is fixed pointwise, of Q adjoin I root 5. In fact, we can go and be a little bit more precise here. Let's scroll back up for a second. What does R fix pointwise? Well, R fixes the P and the R root 5, right? If Q and S were 0, if these parts weren't here, then it would be the identity on that. S fixes P plus QI. If those weren't there, S would be the identity there. And T fixes what? T appears to fix Q adjoin I root 5, the P plus SI root 5. So in fact, we could even be a little bit more specific with our language. R is a Q adjoin root 5 automorphism. it actually fixes more than Q of automorphism of Q adjoin I root 5. S is a Q adjoin I automorphism of Q adjoin I root 5. And T fixed Q adjoin I times root 5, which is like root negative 5. So actually we can be even more precise here. Now, we're really, in the end of the day, we're going to be looking for Q automorphisms. So actually this is all we're going to want. But it's important to get a little bit comfortable with this language. So we also can view them as these sort of automorphisms that fix larger fields as well.